going to go over variables, specifically the difference between variables that reference objects and variables that reference primitives, or I almost should say that contain primitives. So let's first look at variables that contain primitives. Here we declare a integer variable n equal to 5. The way to think of that is Java creates a container, a box, just other words for variables, right? Container and box both imply that you have something that you can put things in, and what's in there can change, which is exactly what a variable is. So that variable n contains a 5, the binary representation of a 5, and a bunch of binary digits, zeros and ones, that represent a 5. Now, it's a little bit more complicated than this, but this is a good way to think about it, right? Now, on the other hand, now let's look at this. So in this case, we're creating an array called list, an array of integers. And actually, we'll come back to this in just a second. Let's just come down here and look at this for a second, because specifically the first line here. So what happens here is we create a box, a variable called list2, when we're telling Java that that box will eventually be able to reference an array of integers. That's all Java knows at this point. So it creates the box and calls it list2. Now, what does it put in that box? Well, you should know by now that it puts null, right? So at the end of this line, that's what has been created. This variable with null in it, and the variable is labeled list2. Okay, now we can come back up here. So here we not only make the variable list, at that point right there, that just contains null. List would contain null. But as soon as we do the new command, what happens is that Java creates a chunk of memory big enough to hold 8 integers. I should say contiguous memory. This is memory that's adjacent in the computer's memory. Big enough to hold the binary representation of 8 integers. That's not really important, but just to be accurate. And what it puts in list is the address in memory where this chunk of memory is located, right? So if you could look inside of list, you would see a binary number, and that binary number would represent the beginning memory, the beginning address of the memory location containing your array, right? Cool. So what's in here, I'll sometimes call this the variable references. The list, in this case, the variable list references the array. Meaning it doesn't actually contain the array. Don't think of the array as being in the box. Like with primitives, the value is in the box. Or you can think of it that way. With variables that reference objects, what's in the box is the location, the address, a reference to the object. And we use this arrow just to graphically represent that what's in the box is not the array itself, but sort of the directions to the array, the address. That's what an address is, right? So coming back over here, when you make one object variable equal to another object variable of the same type, both these variables reference arrays of integers, what actually happens? I think you know, just to make abundantly clear, the address that's stored in here, which we represent by this arrow, is actually copied. That arrow is copied over to here. Oops. Go this way. Right? So list 2 now contains the same address in it that list 1 has in it. So they both reference the same chunk of memory. And if I do something like, say, or if I make any change to the chunk of this chunk of memory via using list 2 to refer to it, obviously, since list is referring to the same chunk of memory, the array that's shared between them, if you change it either place, it's changed for both of them, right? So it's important to know that when you're doing something like this, you're not making a copy of the array. You're just, or any other object, right? This applies to any object in Java. You're not making a copy of the object. You're making a copy of the address of the object into this other variable. If you actually want to duplicate the object, if we wanted to make a duplicate array, that's another process. You could do that by creating a new array of the same size as the existing array, and then copying the elements one at a time. Right? Copying, if you had a new array, say up here, copying the 10 into the 0 position of the new array, copying the 48 into the 1 position, etc. That would actually create a copy of it. But doing this and passing in the name of an object as a parameter to a method, or returning an object name, an object variable from a method, it just gives you the address of the object, in this case the array. It doesn't make a copy of the object. So if you don't understand this, please let me know, because this is a really important concept. If you do understand it, it's going to make everything much easier for you going forward. Okay? Thanks.